All right, good morning. Thank you for being on the webinar today. It's one of our last ones of this year. Today we have Plasson USA, and we're pretty excited to hear what Alex has to say. So we are going to go ahead and turn it over to him. He has also asked that we interrupt him with any questions that we might have. So if you have a question, please feel free to interrupt him. We also do have the chat feature and everything else, but welcome. Thank you for being here.
Thank you, Amber. So nice to meet you, everyone. My name is Alexis Predan. I'm working with Plasson USA, and yeah, I'm going to tell a little bit about myself, and then I will tell a little bit about the company. So I'm from Belgium. Obviously, my accent is showing that I'm not from here. I'm usually speaking French. So I was born in Belgium, and I had a career as an engineer in Belgium. I work mostly in the piping industry. I worked a lot for a company whose main customer was the national water company in Belgium. So I was already very involved in irrigation and piping for city water. The big difference is that I was in stainless steel pipes compared to now, where I'm working with a HDPE. So I didn't have to discover what piping is, but I had to discover what are the advantages of a HDPE over the other material. So I'm going to tell you a little bit more about Plasson USA. Those slides, I'm going to go very fast on those slides just to give you like an overall idea of who we are and what kind of products we are using. So we have a global presence around the globe. The mother company is situated in Israel, and we have different locations in Europe, in Australia, South Africa, of course, in US. We have a few in South America, and what we are, to give you a little bit more details about the history of the company. We've been founded in 1992 as IPS Plasson. You probably, like the company was existing before, but we were a part of Philips Chevron. So we have a longer history, but the company has its activities all around the years, but changed different times of owners and of name. So we became Plasson USA in 2015, and we are part of the Plasson group. I'm actually in the factory in Corsicana, which is in Texas, a few dozens of miles south Dallas, and the headquarters are in Houston. So the kind of product that we offer Spirolite, which is the pipe I'm going to talk to you about in a few minutes. But we also have a lot of fabricated fittings and also a lot of smaller fittings. So we start at 1/2 inch. We do a lot of different kind of little valves and fittings and connection. And most of them are manufactured in United States. For the larger diameter, we do fittings here in the United States in our factory here in Corsicana. And we usually work on orders, so we try to have everything that is custom made for the customer, except for all the products that are made in Israel, who are made over there, and we stock them here in Corsicana. So this is the kind of product that we do. We are specialized in HDPE fittings and couplings. We also have a very deep understanding of electrofusion. We are specialized in electrofusion, but also in different kind of fittings. We provide also all the material to do electrofusion on site. And now we can start to talk about Spirolite. So this is the product I'm going to talk about today. That's the product I'm representing when I'm visiting Colorado. Spirolite is not a new product. It's been installed in the United States since '79, and I found some documents explaining that we used Spirolite already in '89 in Colorado. So on the next slides, I'm just going to give you some example of the different application we can have using Spirolite, and then I will talk a little bit more in detail about what is the product, how it is made, and what is the difference between any other type of pipe or any type of other HDPE pipe. So the first thing you can see on this picture is that our pipe is kind of big. We go up to 120 inches of diameter, 10 feet. So can carry a lot of amount of water. In this case, you can see the relining of an existing culvert. So we are specialized in that kind of situation where you have those existing culverts who have been installed maybe 10, 20, 30 years ago. You probably have seen those big metal pipe, corrugated metal pipe, and going under a road, and over time the water carrying like sand and little rocks can really destroy the bottom of those corrugated metal pipe, and so they need to be replaced. Water is going under, is going around it, and it doesn't serve its purpose anymore. And instead of having to stop the traffic and cut down a new trench and remove the pipe and placing a new pipe, we can reline the pipe. It means pushing our HDPE pipe inside the culvert. We have to change diameter, of course, but we push them, and then we grout the difference between the old pipe and the new pipe. So you have a long-lasting product, easy to install, that doesn't need all the hassle of cutting the road, cutting the traffic, making a trench. So this is the kind of product we are installing. So in this case, it's a sewer installed. You can really see in that picture two things, and we will talk more about that. But first of all, our system is not fused, so it's a bell and spigot system. It just we pop a pipe inside another one, it's very fast. You don't need to wait to heat the pipes. You don't need to wait any fusion time. They are just pressed together, and there is a gasket. I will come later and explain more details about that. That's the first thing you can see here. It is a bell. The pipe is pressed into the next one. The second thing you can see is that our pipe has a rib that is turning around itself. And if you look closer, you can see that it's not rings that are next to each other, but it's really a spiral. And we will talk more about that and explain why there's a big difference between ribbed pipes and spiral pipes. So in this case, it's a 88 inches gasket pipe, and it was a gravity pipe, 12 psi. So in this case, you can see that the pipe is much shorter. On the previous case, we were talking about 20 feet length. Here we have much shorter pipe. It means that we can provide different type of diameter, of course, but also different length according to the needs of the project. In this case, the space where we were going to place the pipe was very narrow. It had to go inside a building, and that was the maximum dimension we could use to go through the building itself, through the door, and then through a corridor. So we can have yeah, it's custom made, so we can do whatever the customer needs us to do. This is a different application using our pipe, which are usually profile pipe. We can also make solid wall pipes and use them to create like a lift station or wet wells. So in this case, we are using a solid wall pipe, and people are used to see HDPE in black. In this case, it's a little detail. Yeah, it's kind of obvious, but it doesn't change much in the way we make the pipe. But the HDPE is white. We don't add. In this case, we haven't added any color. The black is usually, the carbon black is usually added to give more protection against UV. In this case, because the manhole is going to be buried underground, it doesn't really matter, but it offers a great safety feature, because when you open, imagine a vertical black pipe, you open it 20 feet down, even more sometimes, you look down, it's just a big black hole. In this case, just by opening the hatch on top, a few light that is getting into the manhole, and you can see what is at the bottom. You can see if there's an issue with the pump, if there is any water left under. It's really giving a great safety feature. So in this case, that is a big advantage of HDPE compared to steel or compared to concrete or reinforced concrete. It's that you can see at the back of the picture, you can see that there's a sea. And it means that there is, in this case, there is a lot of groundwater, and it's not easy groundwater, it's seawater. So usually seawater is attacking the different component of a metal manhole, or even concrete can go through and attack the different rebars. So HDPE is very stable against any type of groundwater, even if it's acidic or seawater or any kind of chemical. It's really, really good for that. So yeah, this is another picture where you can see the inside of the one manhole. If it was black, you wouldn't see what is inside, obviously. But yeah, it's we had a very big one. It was 28 feet tall. Diameter was it was 120. We just shipped it a few weeks ago to the Washington State, and yeah, it was a very impressive manhole. On this picture, yeah, on the top right, it's the same project we've seen earlier. But on the top left, what is interesting, and it's probably more. It will talk more to you because we're going to talk about the irrigation during some of the next slides. In this case, you can see that we do also all the custom fittings for any kind of connection, turns out, manholes. So we don't only provide the straight lines of pipe, we do also all the connections and anything that is necessary for a complete system. Yeah, in this case, you can see also, yeah, we have a reduction that is shown on this picture, and another type of connection. So basically, anything you can dream about using pipes, we can probably make it, and we are kind of proud of that statement. So in this case, you can see vertical tanks. It's also, we have some tanks here that we are using since over 20 years. They're outside, and they still look great. Like it's a very durable material, and compared to other type of material like steel or concrete, they last much longer. We have HDPE has a lifetime expectancy of over 100 years. So now let's talk about more details. I'm going to read that sentence because every word is important. Spirolite is a specialized HDPE fluid network conveyance systems encompassing pipes, fittings, manholes, and structures made for spirally wound HDPE pipe in open, closed, or solid wall profiles up to 120 diameter or larger. So, as I said, every word is important, and you really have like a very strict definition of what we are doing. We are making pipes, but also everything we can do with pipes, which are fittings, manholes, and structures. The pipe is made out of HDPE, but not like most of the other pipe. The way we make those pipes, we wound them around the mandrel, and that's a very big difference. We'll talk about that more later, but basically all of our pipes, when we change the thickness of them, keep the same internal diameter. So, and it's something very important for manholes, but also for the flow we have in our pipes, because it doesn't matter which class of pipe we are using, we know that the ID will always be the same. So first bullet, single open profile and double open profile. We'll talk about that a little bit later. The most important thing to know is that compared to a solid wall pipe, we do profile pipes. We add air in between the pipe, and it's the same concept as an I-beam in steel structure. You just push the material at the two ends of the profile just to give more rigidity and more structure and using less material. It's the same idea in this case. So we add those ribs over a thin solid wall pipe to give more structure and allow us to have the same mechanical characteristic as solid wall, using less material, less weight, and faster to produce. That's the basic concept. About the standards, you can see we are using ASTM and DIN standards for the pipes, but also for the gasket. More details are given in those standards, but I'm not going to go too deep in those technical parts because it's not the point. That's more what we do every day. But I want to talk more about the different applications instead of really little details about the specification. So yeah, this is an important slide. Why use Spirolite HDPE pipe? So we have different ideas on this slide. And I'm going to try to explain them with the point of view of water conveyance and irrigation. So first of all, we are large diameter pipes. So it means that, yeah, for irrigation, it's good to have big pipes to convey a lot of water. And I know that water is a big subject in Colorado. Spending a lot of time in Colorado. That's my territory, Colorado, Wyoming, and Utah. And so we mostly provide solution for low pressure application and gravity flow. Using Spirolite, you can have different type of connections. So as we've seen on one of the previous picture, it's a bell and spigot connection. We use a gasket, giving us the ability to, I don't know if you hear it, but I'm next to a track and the train is just honking right now. I'm sorry about that. So bell and spigot and gaskets, which is giving a completely watertight joint, which is what we need. We don't want to have water all around the pipe at each joint having leaks. You don't want to have that. You want to have the same amount of water from the start to the end of a pipeline. We have other options for connecting our pipes. They can be fused, so using an extrusion welder or an automatic welder, we can fuse from the inside of the pipe or from the outside of the pipe, or both, depending of the different situation and the different project. We also have another solution. We can electrofuse those large diameter pipes. As I told you in the beginning, Plasson Israel has a great expertise in electrofusion, and when they purchased Spirolite a few years ago, they started to develop the same technology for those large diameter pipe, and we are able today to fuse those large diameter pipe using electrofusion. Other advantages related to HDPE, they don't corrode. It's not like metal or rebars, so they last a long time. The weight too is important compared to a reinforced concrete pipe or steel pipes. They are very light. You need small equipment on site to install them. They are very tough and durable, so they don't break. They are not brittle. It's still it's kind of flexible. It can move and give a little bit, but it's still pretty stiff. It will stay in place once it's installed. We are very competitive when we talk about cost, not only the installation cost, but also we have different ways to ship costs, to nest the pipes. And as I told you before, because we are an ID-based pipe, we are usually able, and we have also a better flow ratio, we are usually able to offer the same flow capacity with a smaller diameter, which is a great financial advantage most of the time. Yeah, the lifetime of the product, we talk about 100 and plus years of service. A lot of people will say, yeah, but like HDPE hasn't been invented since more than 100 years. So how can you say that? Well, it has been tested, stress tested in different kind of conditions. So we can say with confidence that it will last a very long time and probably more than 100 years. So now, why is Spirolite different than other HDPE pipes? The first pipe we can talk about it is solid wall pipe. So the first reason why Spirolite is different because it's usually a profile pipe. It's not a solid wall, and that's a big difference as we talked previously about the weight and the physical characteristic of the product. So now I explained it earlier, and I will show some pictures of our manufacturing process. The pipe is extruded around the mandrel. So as the mandrel has the same ID all along, it means that if we add material, we add to the exterior, not to the interior. So the ID will always be constant. Another point is that we have different kind of profiles. I think the next slide or two slides further away, I will show some example of that. It means that we can really calculate the best solution for a specific application that will be as efficient and probably cheaper than if we were just doing like one same profile. We can vary the thickness of the main wall, the amount of spires. We can change a lot of things to have the best solution for a specific application. Having a profile pipe is of course an advantage in the pipe weight, and it's also giving more stiffness because of the way it's made. So on the upright, you can see one of our extruder. So in this case, you can see that the mandrels are on the left. We have pipes that are ready to be shipped in the middle of the building. The picture on the left, you can see, in this case, we have like a shorter distance between all the ribs. So we calculate all of that according to the specification of the project. And on the last picture, bottom right, you can see one of our workshop where people are assembling different parts of the pipe to make a larger manhole. As I mentioned many times already, we are ID based, so we go from 18 inches to 120 inches, and we have all of those mandrels that give the dimension to the pipe. And you have different views here of the extruder. So as you can see on the left, the extruder itself is on a rail and it's going back and forth, and we have different stations because as we extrude the pipe, there is a lot of waiting time to cool down the pipe. And so while the pipe cannot cool down and stay in place, it has to constantly rotate. So there is no difference in the shape. We want round pipes, of course, and so the extruder is going from a station to the other one, and as the pipes are done, cooling down, we can also work on creating the spigot and the connection for the gasket. Now, I already mentioned that point a little bit earlier. It's that because when we add more material to change the class of the pipe, we add it from the inside out, we keep the same internal diameter. I think you will remember that because I'm saying that all the time. But also because it's a smooth inside, the flow capacity of the pipe itself is higher. And the combination of those two factors allows us to have a higher flow capacity for smaller pipes, which allows us to change usually one size down compared to the pipes of other material or pipes that are not smooth inside. So very fast, this is what I was talking about earlier. It's different kind of profiles. We calculate, we choose them according to the project, the type of soil, the depth of the pipe, and also the groundwater level. So we have single open profile. You've seen some example already. Double open profile. So we double the rib on the pipe. We have single closed profile and double closed profile. They look exactly the same. They are smooth outside and inside. We also have an HS line. It means that instead of it's another extruder. We use, instead of using those round ribs, we use a square HDPE profile, and they are welded together to create that kind of pipe. And we also can run solid wall pipes. You've seen some example with the manholes earlier. So in this case, you can see different things. It's a very interesting picture. First of all, you really can see clearly the bell and the spigot. If you look closer, you can even see the gasket that is already installed. The white line is traced in our factory as we make the pipe, and basically it's this line is showing how deep you need to connect the pipe to the next one. The contractor, every time we install pipes on site, we try to have someone from Plasson USA with the contractor, especially when it's the first time that they install our pipe. And we like to do that. We like to see when our pipes are installed. And in this case, yeah, in every case, one of the main thing to check is that this line has to disappear into the next pipe. And it's a good way for the contractor to know that the installation is well done. It's when that line disappears in the next pipe. It means that the pipe is completely in, and the gasket will be at its best efficiency when it's done that way. You can also see the spiral. You see the start or the end, depends how you look at it, of the rib. And it's hard when you just see the pipe by itself to see the difference between the spiral and just a ring pipe. But in this case, when you see the start, you can imagine that it's really winding around the pipe. So in this case, it's another nice picture of relining. You can see what is interesting in that picture is that there is not a lot of people on site. It's not necessary. So it's another way for the contractor and the customer to save some money on the project. They are not heavy duty backhoes, they are standard ones because the pipe is very light. So that's also something we like to mention, is that on the price of the pipe, the installation of the pipe, you have to consider, of course, the price of the pipe, but also the price of everything related to the pipe and the installation time, which will have a big influence on the final cost of the project. So in this case, you can see a good example of the bell and spigot. I think that this picture has been taken in Colorado, but I'm not certain about that. I will have some other picture taken in project in Colorado, and but you can clearly see that once it's inserted and backfilled, yeah, that pipe will not move anymore. As we mentioned earlier, three types of joint, so we can just have the bell and spigot with the gasket. We can have the electrofusion system, or also just the welding inside or outside, or both. So in this case, the pictures on the right are showing the three different methods. You can see that when the pipe is inserted correctly, the gasket is completely compressed and it is becoming really tight. On the second picture, you can see the two positions where the two pipes will be welded together. And on the third picture, you can see a section of the electrofusion system. So this is something new that we purchased 2 years ago. It's an automatic extrusion welder. It allows us in large diameter pipes to go much faster in the way we weld the inside. So the automatic extruder is extruding and welding pipes 3 times faster than an operator will do. And if you ever tried to weld using an extrusion welder, it's like a gun machine. It's very big, very heavy, and 8 hours of doing that for an operator is really intense. And usually they do shifts during the day because it's really hard. While doing that with the automatic extruder, it's making the work easier for the operator, and we have very good results. The weld is really good and strong, and we are really happy to use that. So we rent it to the contractor working with Spirolite. We have very good feedback because it's lowering the installation time on site. So ease of assembly, of course, it's a very important factor. The faster you go, the easier it is, the faster you can go. So that's something we are proud of too, and we try to promote our pipe using that way. Like any other pipe installed in a trench, you need backfilling and compaction. Where you will really gain some time, it's when you install the pipe, like knowing that we have 20 feet of pipe every single time. It's lowering the amount of joints, and compared to concrete pipe, for instance, who can be much shorter when you reach certain diameters. So by lowering the amount of joints, you can install the pipe faster, and you also lower the risk of any leaks. So some references, standards for backfilling. There is nothing unusual there. It's the standards for backfilling. This picture has been taken in Colorado. I think the project was Fire Mountain. It's a project we did last year. The pipes were installed last year. Yeah, in this case, you can see the way they backfill and they compact. It's nothing unusual. It's same as usual. So as I was mentioning, because the pipe is very light, it's easy to move around. The handling can be done with the standard backhoes on site, and you don't need a large screw. It can be. We have some contractors who have just small teams, and they install Spirolite for relining 2 or 3 times every month in Indiana, and they are 5 people. I have a video about that later. I will show it. Even if we talk about irrigation, what is nice in that video is that you will see the moment where the 2 pipes are connected together, and that's what I wanted to show on that video. So flexibility, that is something that is very interesting with HDPE pipes. Usually, is that they are not easy to break. They can flex a lot. It's very interesting in places where you have a lot of water and then dry alternating. In Texas, we have that kind of issue where it's raining very hard. You have a very wet soil, and then a few days later, during 2 or 3 weeks, it's getting dry. You have a lot of movements with those wet and dry periods, which can break pipes. In the city of Houston in 2019, they had some days over 400 breaks in their water system per day, which is incredible. And that is the kind of issue you don't have with Spirolite, because it can move and give a little bit. And when it has a proper backfilling, it will just move with the ground, and the connection will stay will still stay watertight. So those 2 slides are not very intuitive to understand, but basically the idea is that when you have a rigid pipe, the weight, the loads that are over the rigid pipe are directly pushed back up by the pipe itself. So, but when you have a flexible pipe, the fact that it can give a little bit and deform a little bit will push laterally on the filling material, who will react, and that is the big difference. The pipe is not reacting just by itself to the vertical loads from the top. It will also give and react with, it's the complete system with the backfilling material and the pipe that is giving its characteristics. So a rigid pipe after a while will just break because it doesn't give anything, while a more flexible pipe like HDPE pipe can move a little bit and will react with the backfill material. So shipping and installation, yeah, we ship everything from our factory in Texas. To save on the shipping cost, we always try to nest different diameter pipes all together. So as I was mentioning before, the fact that we can lower one diameter usually compared to other material, we can play with that, and we can reduce from a third to a half the amount of pipes we are going to ship on site, which can save a tremendous amount of money on some projects. So in this case, two Spirolite pipe have been welded together. It's a HS type, so we can go up to 50 feet long on the trailer. So different application. Like I separate in two different kind of application. It's what is buried and what is above ground. So of course you have water transmission, penstock irrigation. This is the most important today. Also manhole lift station, tanks, and all the fittings to go with those applications. And for above grade, we have different industrial application, different vertical tanks. We also add pipes in existing flumes. We did that a few times in California because they had water that was conveyed in flumes, and because of the fires, the ashes were going down on that water, and that water wasn't able to be used anymore for city water. So they had to line the fumes using our pipe to solve that issue. So this is the video I was talking about. It's a relining in Indiana. So you can see that there are not a lot of people present on site. It's along a highway. They are about to push this pipe into that kind of corrugated metal pipe. There is no more bottom. So in that part of the video, you can see that they are installing the gasket. So this is our largest pipe. It's the 120. Each section was 19 feet long. They installed 14 of them. So you can see that it's pretty easy. I think it's probably easier to install the gasket on those large diameter than on the smaller one. So two backhoes, the regular ones, and then you will see how they install the pipe. So the installation itself is the same when it's a relining or when it's irrigation pipe. They just present the two pipes next to each other, balance bigot. You will see that the gasket has been greased. So they lock in place one of the pipe, and then they will push the other one into the bell. So you see the white all around the gasket. So they have locked the already installed pipe in place with that chain. Now at the same time, they're going to pull and push the spigot down, and you will see the pop moment. I hope that it will be visible on the stream video. That's it, and the thumb up. So it's really fast. In that situation, they were installing a new pipe every 15 to 30 minutes. And what is very impressive in this part of the video is that the backhoe is not pulling one pipe. This is the last one they installed. So right now, they are pulling down the existing corrugated metal pipe, the 14 pipes all together. And you can see that they're forcing a little bit on the bell, but it's totally fine. Like, this is a stronger part of our pipe. Our bell is very thick, and we are very confident when we see that kind of video, because we know that it's fine. Like, contractors are not always kind and gentle with the pipes, and we know that we are not afraid of that. We know that they can really be tough with our pipe, and it will be completely fine. So this is one of our projects we have recently in Colorado. So I'm just going to give you some information about that. So we are very active in the Grand Junction area. We had one of the DARPA member who is working with us already. And so in 2019, we had two projects. It's Snow Delta and Fire Mountain. They are close to Hotchkiss and Crawford, Colorado. So we installed some 48 and 72 pipes for those two projects. The installation was very straightforward, and the customer and the engineering company are very happy of the project. At the moment, we are manufacturing some pipes, 72 inches, for the Aspen Canal for the Bureau of Reclamation. We won the bid like a month or 2 months ago, and they are about to install the pipe in December or January. I don't know exactly when will the project start, but we are going to ship our first pipes in December. Another project that we are working on right now, it's a Fruitland or Gould Canal. There is something very specific because we have to reline an existing tunnel going through rocks, and we offer Spirolite on that project because we have the ability to change the length of the different sections, and because of the accessibility, the very small accessibility of those tunnels, because they curve, we had to make very short sections of 2 or 3 feet sometimes to be able to fit in those curves and connect with the next pipe. So that's the perfect example of an application for Spirolite, where we can really have a custom-made product, and we work really close with the engineering company and also with the contractor to be sure that everything will be fine during that project. Yeah, for the Gould Canal, the project started in 2000. There are different phases. It started in 2019, and the next part of the project will probably continue in 2021. So another kind of project that we worked, but it was in Utah, but it's called Spanish Fork, and it was in 2018. And yeah, it's also it's the same kind of irrigation project. So other example, I have another video after that that will come showing the project in Colorado, but just a few other examples here on full-time pictures, or full screen pictures, sorry. So this is the detention center. So in some places where you have so much water coming so fast on parking lots, that kind of detention center is mandatory to keep the water on site and release it little by little. We have a lot of flash floods here in Texas, and this is the kind of solution we are offering too. So this is for odor control in wastewater treatment plants. And this picture is interesting because it's showing that basically we can connect anything to our pipe. So in this case, you have a squared profile connected to HDPE pipe. We do that kind of flanges. As I told you earlier, if you can dream it, if you can draw it, design it, we can make it in HDPE. So we can virtually connect to any type of material, any diameter, and we do that kind of custom fittings regularly here in Corsicana. So this is a project that we've seen. We replaced, we relined the 144 culvert with 120 Spirolite. And so you've seen that picture too earlier. This is one of the manhole for a lift station. You can see the inside. It's much easier to see what's happening. And that customer in Washington State only requires that kind of manhole. Since they started to use them, they don't want anything else because it's really a plus. So I should have a video playing here. Okay, this is it. So this is close to Crawford. It's the yard where we placed our pipes for one of our projects last year. So we try to have everything on site before the start of the project, so we know that the contractor can install our pipes as fast as they want. So you can see on the yards we have those pipes, 2 different diameters. So we bring them nested. It's hard to see from distance, but there are pipes inside the pipes. At the end of the video, you can see also those fittings and different access points. And so what is nice is that we provide the whole solution for the piping system. So you can see how the pipes are nested together and they are attached together to ensure that there is no issue during the transport. So on the right, you can see one of the angled fittings using the balance spigot. Once again, it's a very easy and straightforward installation. And contractors usually really talk very well about our product once they install it. So this is the project. We were going to replace this this canal with our pipe. So the project is done. It's completely covered now, and we have a very high satisfaction degree from the customer. So in this case, you can see how the pipes are stacked. It's exactly how we we ship them, we stack them this way. So another example in Colorado, same project, they prepare the pipes on the side before installing them in the ditch. Same project, Fire Mountain. And you see not a lot of people, just a backhoe there that is used to install. And as they install the pipe, they're already compact and cover the previous one. This is a project in Utah.
I just want to put in there that we only have a few more minutes, and then we can take some questions after that.
All right. I'm reaching the end, I think. So this is another view of the project in Indiana where we relined that pipe. It was after the installation. I walked into the pipe just to see. And so this is some manholes. We send them regularly in Florida. They need a lot of lifting station over there. And Amber, this is it. I'm done with my presentation.
It's great timing. Thank you. I know we have some
you're
questions.
Welcome. Okay.
So anybody can just jump on in and start asking him questions. I know Paul has.
All right, and this is Manny, and Manny has questions. Paul, do you want to go ahead? Or
yeah, you can go ahead.
All right. My first one is, if you install this pipe in an existing culvert, CMP or something that's rusted out, what about fire retardant? Well, when people burn their ditches, what will happen to this pipe if it gets hot?
So it's a plastic pipe. It doesn't like to be burnt. Plastic and fire don't work well together. So we recommend usually in that kind of situation, or to avoid those fires like in California, to have the pipes buried. That is the basic protocol. Now, what happened in California with fires, I've seen some pipes that were burning on the ground, and that's not the standard way to install the pipe. We really recommend to use buried pipes for those two reasons. First of all, because it's giving more structure to the pipe itself. As I explained earlier, the structure of the pipe is really given by the system with the pipe and the backfill. And the second reason is that, yes, if you light a fire on top of a pipe, it will melt and it can continue to burn. So plastic and fire don't work well together, that's for sure.
What I'm really looking at is if you have one in a pipe, and let's say you put an end cap on it out of cement, a stem wall or something,
yes.
Then if somebody goes in that pipe, we have a homeless issue. If they go in there and build a fire in a large pipe in the wintertime, we would have a problem, wouldn't we?
Yeah, that's true. So what we do in that kind of situation is exactly what you said. We have a top in concrete, and we have a safety entry to avoid to have people going in and start a fire. Like, this wouldn't be a great idea for sure.
Okay. Then my second question is on the ASTM rating. Our highway department here uses ASTM 361. I've written down all the ones you show. That is the top load as well as the inside pressure that it'll take. Do you have a way to equalize that 361? Those other ones are probably new ratings. I don't have that rating.
Yeah, I'm not familiar with this 361, but I can look and do some research and come back to you with my answer.
Okay. And then a third question on, do you have a squash pipe or an elliptical pipe? It's kind of like a D shape. You don't make such a thing.
Yeah, I see what you mean. That's a very good question. We always make round pipes, but there are ways to reshape them and make them oval. We work with a company in Indiana who is doing that. They have a system to ovalize our pipe to different specifications. So yeah, we have a way to do that, but it's a third party doing it. But we trust what they do, and we approve the final product that they are doing.
Very good. Those work very good for crossings, street crossings.
Yeah.
All right.
Okay, I see.
A fourth question on backfilling with the material. You spoke of that several times about the strength there. Do you backfill with a certain type of material and just to the spring line, or over the top of the pipe?
So we do backfill and compaction, and we have a protocol for that. It's nothing out of control. It's very standard, and I can forward you the brochure explaining our protocol and what needs to be done. It will give you all the details of our process.
All right, and then all your pipe is manufactured locally here in Texas, and then you can ship that anywhere, like to Colorado or Utah, via the trucks that you were
exactly.
showing. Okay.
So
and
yeah,
then,
sorry, go ahead.
That's all right.
So I was going to say we we have a delay. I'm sorry about that.
All right. On street crossings that are already a bridge, you can fit up to that bridge, is what you're saying here with some of your fittings?
I don't exactly understand your
okay.
The situation you're describing. Can you give me more details?
Right. We have lots of crossings where they're street crossings, and we hook into a box culvert bridge. You could design a fitting that would fit that box culvert and either insert to it. Okay. All right. And then my last question here is on one of your slides, you showed water coming out of the pipe you were putting in. So I presume that you can install that when it's wet, but then do you make a seal, make a seal on both ends afterward to enclose so that the new pipe carries all the water?
So what we do is that we can install and push one of our pipe into a live stream. There is no issue with that. What's happening is that once the pipe is installed, the stream is contained, and we still need to grout the space between the existing pipe and the new installed pipe. Is that answering your question?
Yes, it did. Thank you.
Okay,
and
good. You're
okay,
welcome.
Paul, give it a heck.
Okay, thank you. I also have a series of questions, but I want to first thank you for a very informative presentation. Could you talk a little bit more about why you feel, or if you feel that Spirolite is a inherently better design than circular wall or circular corrugated plastic pipes, such as the double wall ADS pipe?
Okay, so that's a very good question, because a lot of people, when they look at our pipe and ADS pipe side to side, the first reaction is, well, it looks the same, because you have those rings. They're both black. Probably they compare to the same diameter pipe, so they look the same. If you look deeper, you will see various differences. The big one is the bell and spigot connection. When you look at ADS pipe, the bell and spigot are weaker. ADS is a pipe that it's our competitor, of course. I think it has its usage, but I really will recommend using Spirolite when you have like when you need a heavy duty pipe. We know that contractors are not easy on the pipes, and we have a lot of feedback from customers who who switched from ADS to Spirolite because of that. They have a lot of pipes were broken down. They had a lot of issue with leaks. Their bell and spigot connection is not as tight as we have. One of the other difference, and I mentioned it earlier, is the fact that we are spirally wounded around the mandrel. We have the rib in a spiral compared to ADS, who has a system where there are rings. And if you make sections through the pipe, if you imagine that you cut through different parts of the pipe, when it's a ring, you have a different section. The surface that is cut is not the same if you cut before the ring or in the middle of the ring. So it means that just because the way it's made, you always have a weaker point between the rings. Because Spirolite is made through a spiral, every section is the same, it's just rotating, but you always have the same surface of material all along the pipe. And in the parts where we have no more ribs, so where the bell is and where the spigot is, we just add more material. There is more thickness to the material, which ensure that all along the pipe we have enough strength to resist to the external loads. Another big difference, and that is a difference that you cannot see when you look at both pipes, is the grade of resin that we are using. Like we decided that with Spirolite, we always use virgin resin and the PE 100 grade to ensure that we always have the same quality in our product. Now ADS has another vision, and I'm kind of happy they have that. They recycle HDPE from various origin, and I think it's a good thing. But because of that, they cannot ensure the same quality level as we have with Spirolite. So it's just another philosophy in those two pipes. I think there are some cases where we don't compete because we are completely different. But the situation where Spirolite is a better option is mostly when we reach those larger diameters. ADS is 60 inches maximum. We go up to 120. So in that situation, we don't compete. We are the only one on the market. And also another thing you have to take in consideration is the toughness of the pipe and how it will be installed and how easy it will be for the contractor to install it. So we talk about two different products. And did I answer to your question, or do you want me to go more in detail in certain aspects?
No, you did a good job of answering it. I understand what you're saying, and so your HDPE product is, as you say, spirally round around a mandrel.
Yes, exactly.
Is there, as it winds, then I guess it fuses to the previous wind. Is there a risk of it not fusing well or unwinding, with time?
No, not really. I'm going to explain to you why. So the extruder is not extruding a small piece of HDPE at the same time. Like the width of the extruder is a few inches wide, like 4 or 5 inches. I don't know exactly. I'm not specialized in the machine itself. What's happening is that the pipe is the mandrel itself is heated before we start to extrude the material on it. It's extruded at the right temperature to allow the melting of HDPE and the mix of the molecules of the two parts that are connected together. So there are like heaters that are all around the extruder, which ensure that the material is at the right temperature. Besides that, there is some pressure applied to with a counterweight system to push the pipe, to push the material against the mandrel. And once the first part is already on the mandrel, it will push the next particles of material against the first part. So we never had that kind of issue, having a bad fusion between the pipe and the ribs or the different layers of the material. But that's a very deep technical question. Thank you for asking that. Did I answer to your question?
Yes, you did help me understand that. I next want to ask about the gaskets. What is the ability of the gaskets to defend against root penetration? In other words, over time, will we expect to see trees growing near a gasket be able to penetrate the gasket?
So we know that we don't have issue with groundwater getting in. Now, when you have roots issues, we will advise you to have the pipe welded on the outside or on the inside, because we know that the roots will not go through the extrusion itself. We never had issues with roots going in just bell, spigot, and gasket configuration. But now, if you know that you are in a location where this will happen, we will advise to weld the system inside or outside.
Okay, I understand that. And I wanted to ask about the tanks that you showed us. So I guess there must be a maximum height of tank that a person could make, because otherwise the pressure at the lower end, bottom of the tank would risk rupture. So would that probably be about 50 PSI at the bottom, or a little less?
So I don't know the detail of the calculation, but what I can tell you is that 8 years ago, we made our largest manhole. It was made in 3 different sections to transport it, and the total length installed was over 80 feet. I think it was 88 feet tall. And yes, as you mentioned, the thickness at the bottom was over 6 inches, I think, out of my memory. I will check that and give you more details if you want. And what is happening is that the 3 different sections were made using different thickness. So we use less material on the bottom than on the top than on the bottom. But yeah, you're right. In that kind of situation, the pressure at the bottom is calculated, and it can be pretty thick. So we need to calculate that for the bottom itself, but also for the shaft, the sides of the manhole. But yeah, 88 feet was our largest, and it was a 120 inches diameter.
Okay. Yes. Well, that makes sense. And you don't have to research it anymore. I just wanted to understand, or send me anything else. I understand the principle. So my final question is, this was a good presentation in PowerPoint, and I appreciate you sharing it with us. Do you have any PowerPoints that are publicly available that that you could make available to us for reference?
I will transmit to Amber this presentation in PDF, And I also have a presentation I made 2 or 3 weeks ago specific about manholes. I will give that to her too. And on that last presentation, I'm talking about manholes. There are a few pictures where you can see how thick those manholes were, the tall ones. And you can see also the welding process to connect the different parts of it. It's pretty impressive. And yeah, we are proud of that kind of product. It's not something we do all the time. It's very specific, and but we are proud to be able to offer that kind of product to our customers, and they come back. It means that they are happy of what we offer. So I will give her those 2 documents, and she will share them on the website, I guess.
Okay, well, thank you for answering my questions. That finishes my questions.
Okay, thank you, Paul.
Do we have any other questions from anybody else? All right, hearing none, we'll go ahead and wrap up this webinar. You can absolutely email me, or I can give you his email and we can get those questions answered for you after this webinar too. But thank you again so much for being here today. We really appreciate you. All right.